we are going to go ahead.
All right, thank you, Caitlin. Good morning, everybody. So welcome to the Third Son's COVID stay-at-home webinar. Today the subject is backup battery power for resiliency. It's a really popular subject. On our Third Son Solar on Third Son Solar web page, we've got a blog, and our most popular blog post of all time is backup power during a power outage. And so it's definitely a subject that a lot of people are focused on. So today we'll give you a quick little introduction about who we are and why we can speak from experience on the subject. Talk about the reasons people are interested in storage. Talk about technology options that are available to folks that want to do some storage. Take a deeper dive into a case study of Hooper Ridge, my personal house. Talk about some of the data and control features that today's modern storage systems have. Go over sizing and budgets. One of the most important topics. People are often quick to say, well, how much does it cost? And what do I need to pay for? And what options are there? And then, as Caitlin said, we're going to have time for Q&A. That's the best part of these presentations. So if you're online, submit a chat, and Caitlin will be kind of combining questions. A lot of people will ask a lot of similar ways to ask similar questions. And then we'll also be able to save those Q&As near the end. So without further ado, I'm going to jump into who is Third Son Solar? We are in our 20th year of operation and headquartered in Athens, Ohio. Let's see, I think I'm seeing Michelle tune in. We got two Michelles. We got two people logged in as Michelle. That's great. In any case, Athens, Ohio. We're a full service solar installation company. Been doing this since batteries were the only way to go solar. We do residential and commercial projects. We are basically focused on quality and durability is what kept us alive over the 20 years of working with customers. Do very large projects and small projects and agricultural projects and federal military projects. But most of our work in terms of the number of projects is residential. And we go Cleveland, Cincinnati, Columbus, everywhere in the state into Western Indiana, Northern Kentucky, Eastern Indiana, Western PA. So without further ado, we'll jump into the why storage part here. So the obvious one is backup power should the grid go down. A lot of times the grid goes down and comes back up. It's really quick. It really depends on where you are in the state and how severe of an outage it is. On the one hand, you could be down for an hour and a half and your freezer and fridge is going to be fine. It's a slight inconvenience. You light some candles. On the other hand, many of folks that might be watching this remember some of the bigger ice storms that we've had where parts of the state were without power for more than 2 weeks. It certainly moves from being an inconvenience into being a real tragic situation, especially folks that depend on electricity for some of their home healthcare needs, and not just losses of stored food in the fridge. People more and more work from home as well, so having reliable power means a lot of different things to a lot of different people. The less obvious reason people are doing storage are for some of the technology where storage interacts with solar. So one of these places is what we call self-consumption mode. Now, if you're into solar or you have solar or you've been researching solar, you already understand about net metering, where you can buy and sell power with the utility And if you're making more power than you use, you export that power through your meter out into the utility grid for a credit. That system is great. There's lots of different ways that it works in different parts of the state, depending on the utility that you have. But for most of us in Ohio, if you export power, you're compensated less than if you just avoid purchasing that power. And so by having a battery as part of your solar system, you can actually avoid exporting a significant chunk of power. So this is called self-consumption mode. So the other interesting thing that storage can add to a solar system is allowing us to do time of use modes. Many utilities, and it's a growing number, and more of our future utility rate structure is going to reflect the more expensive power when everybody wants power, typically in the late afternoon when air conditioning loads come on. And then power is very cheap during the peak times of the day, the solar peak times of the day. And so one of the features of a lot of these storage systems allows you to do time of use, where you can avoid purchasing power during the expensive times and then program your system to only export power during the time when the power is going to compensate you the best. So the technology options. So here on the far left side of your screen are the good old-fashioned lead-acid batteries. I mentioned living off-grid, and Third Sun Solar, back when we started, was primarily working with battery-based systems with off-grid customers. And these are very old technology, 100+ years old. Sometimes they call them the Edison Battery. Very simple, lead acid. It's dirty. It's inexpensive on the one hand, but it also doesn't last very long. So if you add it up over 10, 15, 20 years, it actually becomes a little bit more expensive over time. So the picture there is a battery bank that's got about 14.4 kilowatt hours of storage. kWh, kilowatt hours, how we kind of measure energy in a battery. But then you'll note that I put down 50%. So in a typical lead acid battery, when we design a system, we calculate the amount of storage needed, and then we only can use the top 50% of the battery, because if you regularly cycle below 50%, the battery will wear out even faster with those old-fashioned lead acid battery technologies. So really what you're looking at there is about 7.2 kWh. The next picture is an LG Chem battery that we installed maybe 3 or 4 years ago in someone's basement. We've installed many of these. It's LG is the big consumer electronics company that everyone knows. They make refrigerators and tons of other things. So they make lithium-ion batteries. LG Chem is a fine battery. We've installed many of those, and that unit right there is 9.8 kilowatt hours. An interesting thing about that battery is it does not have its own integrated inverter. It's just a battery, so it needs additional equipment and is part of a larger system. And then there I am next to our Tesla battery that we'll be talking in more detail on later. So that single unit is 13.5. The most popular installation we do is a pair of those units, so 27 kWh. And then we can actually stack 4 of them together in a residential application. So it's up to 54 kWh. And then on the right is a newer product called from Generac, which is a pretty big generator manufacturer. They purchased technology from a company called Pika that I've evaluated. I've been to their factory. I've dug into the details with a lot of my friends. And that battery can come in a lot of different sizes, but it's typically 8.6 kWh. And then you can add more and more batteries within the larger cabinet, so up to 17.1. And all these batteries have pros and cons and different price points, different values. And I'll talk a little bit later as to why I personally chose the Tesla and why our company does lead acid batteries. We do LG Chem batteries, and we do Tesla batteries. So some of the design considerations that our experts will go over with you if you want to go forwards or learn about these systems is it all depends on your specific application. Are you adding on to an existing solar system? If so, how big is your system? What kind of inverter do you have? Do you plan on adding more capacity to the system over time? What are your budget targets? Are you going to be financing this or paying with cash? A lot of our systems, people are going to finance them. We actually have financing that make it really easy. We don't have to go to a bank or credit union. We can finance these, right in the comfort of your own home with a computer. Are you focused on being 100% off the grid, a true cabin or small project in the woods, or even a mega mansion, survival shelter where you're going to be writing a really huge check in order to have your dream system? Doesn't really matter. If it's off grid, it's a whole nother world and needs a whole nother approach. We do all those kinds of systems. Do you want to design with something that you can start with now and then expand over time? And then probably the biggest critical question during the design process is, what are you trying to back up? Are you going to back up just your essential loads, some lighting and some outlets in order to run, a utility, I'm sorry, not utilities, but run the internet and a laptop? Do you want to have your fridge and a deep freezer in the basement backed up? Do you have a well? Do you have sump pumps? Are you looking to back up your whole HVAC system, your heating and cooling system? Is your heating and cooling with natural gas or propane? Or do you have a geothermal or an electric furnace? Everyone's different. So we are a custom design company that has our engineering team and our solar consultants analyze your system with you, walk you through the options, give you size A, size B, size C, lots of options. And if you have a system, was it put in to be storage ready? What do you have if it is installed by us, or we're installing solar storage systems for folks on a lot of the companies that have been out of business for a while, or folks that are not happy with the company that put in their solar system. We're happy to come work on that system and give you solar storage as well. All right, the good stuff. I've always wanted a Tesla, and I've also never written the check to buy a big fancy Tesla Model S. But now I've got a Tesla in my garage, and I'm pretty stoked about it. This is our house in Athens County. So it's evolved over the years, but we started with a 500 watt system, so a half kilowatt system. And then we had kids and evolved, had a home office, started Third Sun Solar out of that third floor up there. And the current state of our system is just over 7 kW roof mounted. The system was off grid. We've been through many battery banks. I told you that lead acid battery banks have a short life. So I know that firsthand. We've paid for several battery banks over time. So this is our current battery bank. It is clean and neat and in our garage. And so yes, I've got a Tesla in my garage. So over here on the right is the solar inverter that takes the power from my rooftop, converts it into the 240 volt AC that the utility uses, and injects it into my whole house system. So this is my load center, my regular breaker panel, and this is the sub panel that the protected or backed up loads are. So my house does not have the car charging, the electric hot water, or the geothermal HVAC system backed up. So when the power goes out, all my lights, all my loads, my fridge, my garage door opener, everything is backed up except for my heating and cooling system. I could have backed that up. I would have just had to put in more of these units and written a larger check. Um, this unit here is called the gateway. You can see these little black antennas on the top. It talks to my internet. I've got right here, I can pull it up and find out exactly. I'll just do it right now. I'll get on my app, my Tesla app, and find out the system is at 64% full. It is charging. I have no power outage back at my house. So we'll talk a little more later about what the capabilities are of the Tesla app, but it's pretty cool. So this kind of controls the power going in and out of the battery, how it interacts with the solar system, how it interacts with the utility grid when I'm tied to the grid, and then how it interacts with my backed up loads if I'm in a backup mode. So as I said, we tied in an existing 7 kW solar array and my existing inverter. We have very small loads. My whole house might have if you don't count the HVAC, I might have a $10 a month electric bill now that my kids are gone. Back when they were home, watching a lot more movies and video and such, it was closer to $20 a month. So for my house, it was only a single power wall. It was all I needed. It's very rare that a typical North American house is going to use a single power wall. Our most popular system is a double, a 2-pack, or a triple, 3-pack. So we'll talk more about that in a little bit. So again, this is off the Tesla website. So this shows you a system where the power wall will back up the entire house, the solar inverter, the main panel, the gateway, and the utility meter. And then this system has an additional box of what they call an essential loads. So sometimes we'll pull loads off of each breaker in the main utility panel and make what we call a sub panel or an essential loads panel. And so during a power outage, only those loads will be backed up. There's another technology that we can use where we basically have smart breakers, and we can add breakers into the main panel so that when a power outage goes out, it turns off loads that are too large to be backed up. So that's another technology that we can play around with in your design. All right, so data and controls. So I talked about my app. So here it is. It's kind of hard to see. Oh, there's my wife, Michelle. But we can see real time what's going on. And so right now, I've got 400 watts of solar, and my house is consuming 4.4 kW. So I've got 4 kW coming from the power wall serving my house, and all the power from my solar is going into my house, and I've got none coming from the grid. And this fluctuates throughout the day. It's all automatic. It's computer controlled. This screen right here, I'll tell you a little bit about. This is a pretty kind of nerdy, energy wonky app, but a lot of people that are into solar are really into the technology, and they get into this and they want to know all about it. So right now, I can look at just my home energy use. So this is from Monday. So my house used 7.9 kWh that day. And you can see the spikes. You can see, the refrigerator cycling is mostly what's causing these spikes. And maybe some stuff in the morning, we're cooking, we're using the toaster and the coffee maker, and some more lights and base load in the evening. This changes all the time. I can see my HVAC going when I'm heating in the winter or cooling in the summer. So then this is a typical solar day. You can see the power comes on in the morning and peaks at solar noon. And these little spikes going up and down are clouds. It's a lot of fun. Again, I can really distract myself by checking on my system no matter where I am at, or I'm even out of town. And I say, oh yeah, let me show you what my system's doing. And I can talk to my friends about solar. So that same day, I made just over double what my house used. So what did I do with that power? Well, this screen right here shows what goes into and out of the power wall. So when it's negative down here, it's actually charging the power wall. So it's going into the power wall. And then up here, these spikes going upwards are where we are using power from the power wall. And this is because I've got the system set up to self-consume. I've got it set up to always keep a reserve in my power wall for a power outage, but then to self-consume. And so you can see the effect. This is my grid. This last chart shows what goes into and out of the grid. So here, before the sun came up, I'm using power from the grid. It kind of mimics the load profile of my house. And then you can see that the sun is out during the middle of the day. I'm making all the power that I use in the house, and I'm exporting. This is the net excess generation that I'm spinning the meter backwards with, and I'm charging my solar power wall, and I'm spinning power out to the grid. At this point here, at about 1 o'clock, my power wall was full. I hit 100%, and because I only have one, I can't keep storing my power. So that you can see that it jumps, and I start exporting a lot more power to the grid. Okay, that's a lot of nerdiness and geekiness and solar engineering stuff. But again, it's one of the fun parts. So here, right here, you can see when I did the screenshot, my kind of fuel meter was 92%. And this is kind of a profile of what I did. I can go back in time and look at each day since I put it in, or I can change it and look at it on a weekly basis or a monthly basis. So metering is fun. We'll talk about controls in a minute. All right, sizing and budgets. So how many do I need? So when we're designing the system for a client, one of the first things we looked at is instantaneous load. How much are you trying to power with your unit? How much power has to come out of the unit at any point in time? Are you running 10 light bulbs, or are you running 10 light bulbs, 2 aquariums, a hot tub, an HVAC, and 3 refrigerators? So that's how much power we need to design around. And I say worst case, that's kind of the term we use is basically the toughest case. If you assume all the loads are on at the same time and we want to power them, we add them all up, and we have to size the number of power walls based on that. The second big component in our design is how long do we want to power your system during an outage? Do we want to be able to ride through a typical 2.5 to 4 hour outage? Or are you preparing for a longer ice storm, a utility outage? Out in California, they're dealing with wildfire outages. We've got people that are not sure, what the world's going to look like in 2 years, in 5 years, in 10 years, and they want to be able to run, forever if the grid goes down. They're not sure that they can rely on the grid. Everybody's different, and so we start with what your goals are and what your needs are, and we come up with your options. The other piece is load management. A lot of times we might come up with a 4-pack system for someone, but then if they say, okay, I know that I can go home and I can turn off the power to the hot tub. I don't need the hot tub to be on during an extended power outage. So then we can drop it down to 3. So load management's part of it. And then the last component in design is what size solar array are you dealing with? That's one of the other components with how many solar power walls we put in. Is a typical single power wall can be sized to about 7 kW of solar. So if you've got a 10 kW solar array, you're going to need 2 power walls, for example. So lots of different considerations, and our experts will walk you through all that and give you your options. So here, it's hard to see in this picture. This is a double stack. So there's 2 power walls front and back, and this customer already had 2 SMA inverters. They've got a nice ground mount system. And then here is the power wall, and here's their backup load center. Here's another install we did in the garage. I pulled this picture up because you can see it's not resting on the deck. These units can be up on the wall. I've seen some of our installs. Our technicians and electricians do beautiful work. They're proud of our pipe work and our conduit bending and dressing these things so they're showpieces. The power wall's got a nice little green LED light, and I don't know, we like to make these things aesthetically pleasing. All right, the good stuff. If you get on the internet, you can go straight to the Tesla website and find out that the power wall costs $6,700 per unit. The gateway costs $1,100. So you're going to also need the pipe, the wire, the breakers, a sub panel. You're going to need the engineering, the permits, the inspector, and then we are a licensed electrical contractor, and we are also certified Powerwall installer. You can't do a Powerwall without having a certified installer install it to maintain the warranty and obviously do it safely in a way that's going to perform well. So all in, the typical costs per Powerwall is between $11,000 and $14,000. And this is if we're tying it in with a project that we're already doing. Most of our customers are putting solar and a Powerwall in. And so it's going to be at the lower end if you're putting in 4 Powerwalls, and if it's just a single Powerwall, it'll be at the higher end, because we only need one gateway no matter how many Powerwalls you install. And of course, we'll retrofit a Powerwall to another system. It'll be a little bit more expensive for that. And then of course, everyone's different. If you want to do something really fancy and complicated, it can be a lot more expensive. And we're always trying to do things as cost effectively as possible. So your mileage may vary. That's why each system is a custom system. All right, let's see, what are we talking about now? Oh, we're on to Q&A now. So I'm going to go ahead and open it up to Caitlin to moderate for a Q&A, and I hope this has been helpful. It is a very high-level introduction, but if people are interested in solar or interested in solar plus storage, that's what we do. We talk to people every day. We've installed thousands of systems for people, or I'm sorry, more than 1,000 systems, and pride ourselves on answering questions and hopefully helping people go solar. Caitlin, what do we got?
So we do not have any questions yet. We do have some attendees here. If you would, anyone who's watching, if you have a question for Jeff, go ahead and navigate towards the bottom of your screen. There's a chat feature. If anything he's brought up has kind of spurred a question, or if there's anything you've ever wanted to know about solar batteries, solar backup, in general, go ahead and drop it in the chat box below. And if you're joining us on Facebook Live, you can feel free to go ahead and do the same. We're watching those comments as well. And all right, so we do have one question. Bruce asks, are they always installed inside? Do they need a controlled environment for temperature or other?
Yeah, great question. So there is an operating range. They're advertised on the Tesla website as being able to be installed outside, but we recommend putting them inside. If you want your backup power in the winter, you're going to want to have it inside. It can safely be installed outside, but it shuts itself off if the temperature is outside of that operating range. And so if backup power is what you want, you certainly don't want to have your nice fancy Tesla battery pack shut off because of cold temperature. Thanks, Bruce.
Kevin's asking, how much wall space is recommended for a similar setup in your house? And can the components be located far away from each other if space is limited?
Yeah. So one of those pictures, you saw the power wall by itself, just up on the wall in the garage. And they don't have to be all associated next to each other. Because the voltage is not at the old-fashioned 12 volts DC where line losses are a pretty major component of design, we can put these things 100 feet away from your utility meter or from your solar inverter. So they can be spread, throughout the house, A. And then B, the wall space, the gateway itself, I don't have the exact dimensions, but it's about, I'd say about 20 inches by 24 inches. So that right there is the gateway. And then the solar wall pack itself, I should probably know this by heart, but it's probably about 30 inches by about 40, maybe 44 inches tall. And again, they can be stacked 3 deep or even 4 deep if they're on the ground, or if they're on the wall, we can hang them on the wall. So hopefully that answered your question.
Great. And just so everyone knows, we're getting quite a bit of questions. So I'm going to try to get through as many as we can. The next question we have is, how does an existing grid tied, I'm assuming you mean house, how does an existing grid tied system incorporate battery backup? And what is the lifespan of battery packs?
I didn't even touch on lifespan. That's one of the main reasons why I went with the lithium-ion. So let me answer the first question first. So in my house, this was already up on the wall, and we had the main panel already. And so that was a net metered panel, no batteries, and we simply retrofitted the solar. We added a sub panel and the gateway and the storage, and it works well. That's one of the reasons we like the Tesla. The Tesla will work with any inverter, no matter what inverter you have, what year, what technology. It's what we call an AC bus. So it doesn't ever touch the DC wiring from your solar array down to your inverter. It works on the AC side. So we can put a Tesla in. With some of the other technology, LG Chem, for example, we have to use a storage, SolarEdge storage inverter. Not everybody has those. And on the older technology, and we still do the older technology, we would use a lower voltage specialty inverter from Outback or from Magnum. That's a 48 volt DC inverter. And in that case, the wiring on the rooftop or out on the ground mount is wired at lower voltage at maybe 48 volts. And we do have to size the wires a lot larger. The installation becomes more expensive and less efficient. And it's more of a technology for a smaller off-grid cabin. The second question, I'm glad you asked, is how long do these things last? The lithium-ion technology is not susceptible to the degradation that conventional lead acid is. Lead acid technology, the more you use it, the cycles of emptying and filling and emptying and filling basically create a crystallization on the outside of the lead anodes inside the battery cell. And more of those crystals take up surface area. That means less and less of the lead antimony is available for the chemical reaction. And over time, maybe 5 years is about what a lead acid battery will last. Maybe it will last 8 years if you really baby it and take care of it. I personally am a solar expert. I own a solar company, and I have killed a lead acid battery bank in less than 5 years. I'm guilty of doing that. It's hard to make those old-fashioned battery banks last. The lithium-ion battery bank, you don't have to care and feed for it at all. It's all automatic. There's no electrolyte to fill up. There's no messy, dangerous, toxic chemicals to deal with. I think that it is, we should look this up on the warranty page on Tesla. So it's either 8 or 10 years warranted. And then the existing expected lifetime really is going to depend on your usage patterns. If it's always in backup mode and you're just letting it float there, it's going to last maybe 20 years. If you're cycling it up and down every day because of self-consumption mode or because of time of use mode, that wear and tear on filling it and emptying it is going to make it maybe need to be replaced in closer to 10 or 12 years.
I was just working on a blog post yesterday, and I'm pretty sure it's a 10-year warranty. But we are getting a question, if your garage or basement floods, are they protected or will they be ruined? Can they be high up on the wall to prevent this?
So we don't want to test it, but they have survived floods. So there's a lot of cases where water will actually, these things, because of the way that they're built, they are hermetically sealed inside. There's electronics up here, but this area down below theoretically can get wet. Now that said, why in the world would we ever want to take that risk? Yes, we can put them up on the wall. They're heavy, but they can be attached to a drywall wall with 2x4 studs. There's a special bracket, and we can hang them up on the wall. And that's what I would recommend if they're in a flood-prone area.
All right, great. And our solar designer is chiming in that 70% at 10 years. A couple similar questions we're getting here. Does temperature make a difference in storage capacity of the storage unit, as well as you mentioned a temperature range for the operation of the power wall? What is that range?
Well, sounds like Jack is on, and so I'm going to let him chime in on the range or whisper in Caitlin's ear. But yeah, temperature does impact the performance of the lithium-ion. And so the system itself has a temperature sensor built in. And that's one of the reasons we don't want to have it outside in Ohio. And so I think that if it's super, super cold, it will have a less available power. Let's see what Jack says.
All right, we will wait for Catherine's answer. Catherine's actually on. And
so, actually, we've got two engineers, and both of them are turning into Tesla nerds because we love this technology. So thanks, Catherine, for looking that up.
We got a question: how much does it cost for an estimate to install a solar power or to install a power wall for an existing system?
That's great. Some customers or some solar contractors charge for their estimates. We do not. We're happy to talk to you about your solar storage options, either retrofitting a solar system that you already have or putting in solar and storage. We do offer that free service by doing it remotely. It would be very expensive to drive out and meet with you on site. So what we do is we work digitally, which we've been doing for years that way. It's now becoming very popular with the coronavirus. We gather your electrical usage information from your utility bills. You can take a picture and show us what the layout is. There's a lot of email back and forth, and then we'll come up with some options and go over them with you on either a Zoom call like this or a telephone call. Or some people just good old-fashioned email. Once we decide on what fits, and you say this makes a lot of sense, let's dig into the details. Obviously, we're going to be on your property, in your basement or garage, up in your attic, taking all the measurements, figuring out exactly the specific details for the installation. Yeah, so long answer to a short question. We will provide an estimate for free.
Great. And Catherine is getting back to us. The temperature range for the power wall is -4 to 122 degrees Fahrenheit, but the recommendation is 32 to 86 degrees Fahrenheit.
Thank you, Catherine.
Yeah, thanks, Catherine. So another question, this is an interesting one. Do you think the Tesla batteries are more widely used, and I'm guessing the question is, do you think that as the batteries are more widely used, will the price come down?
Yeah, the price has come down and it's tied into mass production. So that Tesla Gigafactory that was built down in Utah is where these batteries come from. And it's the same battery that goes into the EVs. And it's primarily the popularity of the EV that's driving this. Now, will the battery cost less in 2 years versus today? I don't know. I've researched that question for myself, and because I was deciding, when am I going to buy my next battery and replace my old lead acid batteries? Um, I decided that the price of waiting was higher than whatever potential savings I might have by waiting 2 years. So get on the old interweb and do a Google search of lithium-ion, price curve, and you can see that it's dropped pretty sharply over the last 10 years, and then it's flattening out as there's diminishing technology improvements in mass production. One of the components here is the actual price of the lithium, the price of the steel, the price of the other electronics that go into this plain white box. And so those things are all commodities tied onto a global market. I did some research myself. I was really concerned about the environmental impacts of my choices. And there's some stuff on the internet about lithium being a terrible thing. It turns out that the lithium being used in batteries is a very small part of the global lithium use. The primary role of lithium in the world is in paint and in grease or lubricants, and then in medicine. And then, after a couple of those uses, it starts to get into EVs. So just like anything we do, we have an environmental footprint. I care greatly about the environmental footprint, and we've gotten into a tangent here. But the price of lithium is one component here, and as supply and demand go up for EVs, the price of lithium is probably going to be balanced out. So we don't see it coming down much more over time.
Great. Kind of an off-topic question, but it kind of goes into some of what you've been talking about, Jeff. What kind of solar panels do we use?
So there's a couple of different types of solar modules. We've used, I don't know, about 20 different suppliers over the years. And what we look for is reliability. You're making a 25 to 30 year project investment. You want something that's going to last that long. And we want the company that's making it to be around in case there are any warranty claims. So our most popular solar module right now is from a company called REC. They're a Norwegian company, been around for a long, long time. And their headquarters is in Singapore. They manufacture primarily in Singapore and Malaysia. And so we use them. We use LG. We use Hanwha, a big Korean company. We have SunPower modules. They're a globally manufactured US company. So yeah.
Great.
REC.
So an off-grid question here. Would a system with Tesla Powerwall could it take you off-grid theoretically, or is it just to add on to a grid-tied system?
No, not theoretically, absolutely. So Tesla Powerwall is made to operate in an off-grid mode. Depending on the size of your project and how much power you want to provide, we might specify a Tesla Powerwall. We might specify another brand of lithium-ion batteries. We might specify a small, lead acid battery. So every customer is different, every project is different, and we've got different solutions in our toolbox for these different applications.
Great. And it looks like we've gotten to a lot of the questions that we've had so far. If you want to, go ahead and send in additional questions, and we might be able to get to them. And I'll just put a plug in right here. If you are live with us on Zoom, we will follow up with an email, so be looking out for that. We'll include some backup battery resources, some of the information that Jeff shared, as well as a link to get in touch with us in the case that you would like an individual consultation for your home. And we'll also send you a link to a survey. We're really interested in engaging with you all in this way. And we'd be interested to learn, what else are you curious about? What else are you interested in learning about? And we'd love to continue engaging with you like this. And I haven't seen any additional questions come in, Jeff, so I will just leave it at that. Go ahead and check your email. We really would appreciate responses to that survey we'll send, and you can expect that from us soon. Any closing words, Jeff?
Yeah, one more reminder on this program format. I believe that this video is going to be archived and available for my great-grandkids to watch someday. But I think at the Third Sun Solar blog site, we've got information on batteries as well as solar. So if you're curious and just want to learn about it on your own, go to our website and poke around. And like Catherine said, we are not out there, trying to sell solar at all costs. It's the majority of our systems are with people that have decided to go solar, but for every system we install, there's plenty of people that have asked about solar, learned about solar, gotten quotes, and we tell them, no, it's not a good fit for you, or you can't do it for your budget, or we don't recommend that you try to do it. Our philosophy is to help people get the information and make a good decision. So feel free to call us, and don't feel under pressure that you're going to have a hard sales pitch. But if you go solar, you get a mug and a t-shirt, and you can talk to Catherine and the rest of our team. Thanks a lot, everybody.
Thanks everyone for joining us. We'll talk soon.